ACLs.
Yeah, it is. So everybody, welcome to our Routing, Switching Essentials class meeting for the week of 8/2/17. We're going to talk about access control lists as it relates to the CSEN exam. The good news is that ACLs are much shorter than they used to be because we did remove, or Cisco removed, extended ACLs from the test items for CSEN. Now, they still mention them in this chapter, but it is important to note that we're only going to be dealing with standard access control lists, numbered and named, and also with the access class, or basically using standard ACLs to control access to the VTY lines as we SSH into them. Now, what are access control lists? Well, they are a series of permit and deny statements. That is their primary function. They are not extremely intelligent, so it's a series of permit and deny statements. Okay, they are applied and read top down in sequential order, which is very important when we start building our access control list, because we're going to have to think of the logic that's available. They end with an implicit deny all or any. So in other words, if no access control list entry or ACE applies in the access control list, the final access control entry is always deny everything. So this is very important when we start building access control lists and look at our logic. We are going to learn that you can have one per protocol, per port, per direction. The 3 Ps we'll talk about. And honestly, they're not extremely smart. This is what we would call just basic packet filtering. So it's packet filtering at layer 2, or excuse me, layer 3, layer 4. It's not stateful packet filtering. It's not the ability to do a stateful firewall. It is just the ability to do packet filtering. Sudhakar, you can't hear me, or can you hear me? You may want to disconnect and reconnect if you cannot hear me. Patrick, you can hear me, can't you?
Yes, I can.
Okay. Try to disconnect and connect, or make sure you tell your PC that you're going to call in using the PC, because we're using voice over IP only. So since Scotty just got here, she's got to explain all these things that we have. No, I'm just kidding, Scotty. But it is a series of permit deny statements. They're applied top down, applied and read top down in sequential order. They end with implicit deny all or any, and one protocol per port per direction. It's also important to note that the very first entry, access control entry, that applies to a packet will be the one that takes place. So again, that's where we've got to really think about our logical order for creating these access control lists. So that's what it is. What can they be used for? Well, you know, I'll be honest with you. Here's the thing that's a very important item about access control lists. Like IP addressing from introduction to networks, ACLs are something that will be used throughout your career with Cisco. They're used for everything. They're used for obviously filtering traffic, controlling access to VTY lines. They're used for route distribution, route maps. Just the many different things they're used for is just unbelievable. So it's extremely important you understand how ACLs work. You'll even learn here a little bit later in the next chapter that an ACL is used for NAT to determine what will be NATed and what will not be. In addition, ACLs are used to determine what is considered interesting traffic for VPN creation. So they have a huge amount of use in the iOS and on Cisco devices. So it's important that you really get these down and understand them clearly. Now, they're not just for security, by the way. They are for filtering traffic and security, but they're also for traffic flow control. They're for ensuring that resources on your network are used correctly, and many other items inside of a network. They do packet filtering, again, filtering only at layer 3 and layer 4, so they are not very smart. And there are ways to filter. Really, with layer 4 filtering is when you're doing extended ACLs. We won't get into those in this particular course. We will get into those in scaling and connecting. So we'll talk more about those after we go there. Standard ACLs only filter based upon the IP address. In fact, standard ACLs only filter based upon the source address. So we're going to be dealing with standard ACLs, and they filter based upon source IP address only. So they're very simple. They're very simple to set up and to use. There we go. I can hear you, Sir Gar. Can you hear me now? It looks like you're getting voice. Now, one of the important things to remember is ACLs are applied either inbound or outbound. Now, it's a little confusing until you think about this. I want you to stick a person in the middle of this router right here. So right where my cursor's at, right here in the center of these arrows, stick a little person in there. Inbound and outbound is always seen from the standpoint of the person sitting in the middle of the router. So if I was to go this direction, which is to the left of this inbound, that would be outbound. If I was to come into the router on the right here, that would be inbound. So it's always looking at the person in the router, okay? Don't get confused by that, because you're going to have to place the access control list on interfaces that are either inbound or outbound as where you will place them. And you need to really think about where the traffic is going, where it's originating, and also from a standpoint of not using excessive bandwidth, you need to think about how you can place these to keep a packet from being routed and then dropped on the exit interface, which is something that wastes bandwidth and resources on the router. Now, what do ACLs use? ACLs do not use subnet masks. ACLs use a wildcard mask, or what is many times described in documentation as an inverse mask. Okay, so wildcard masks are many times called inverse masks, which means this: in a subnet mask, what bits are significant? Ones or zeros? In a subnet mask, ones are significant, because think about it. If I give you a subnet mask of 255.255.255.0, that is telling you that the first 3 octets are the network portion of the address, and the last octet we don't care about because those are the hosts. There you go, Scotty did it, it's ones, okay? Now, in a wildcard mask or an inverse mask, wildcard mask, zeros are significant. So we would convert a mask of 255.255.255.0. The wildcard mask of that would be 0.0.0.255. We reverse the ones and zeros. So that's the easiest way to convert a subnet mask into a wildcard mask. What's very important, though, is quite honestly, without a preceding IP address to compare it to, a wildcard mask is fairly useless. All I can say here is that the first 3 octets have to match, and the 4th octet we don't care about in this particular setup. This becomes much more important when I do the following: 192.168.12.0.000.255. This, if I put this in an access control list, matches any packet that has 192.168.12 in the first 3 octets. So if a packet come in here, and let's say I'm going to put a permit statement. I'm going to say permit that, okay? And a packet comes in here from 192.168.12.17, that packet would be permitted. If it comes in from 192.168.13.17, what would happen to it? And I know I'm ahead of what I'm teaching you, but it's okay. All right, Scotty's right. It's not going to be permitted. It's going to be compared to this access control list entry. It does not match because it was 192.168.13.17. And then it's going to hit the implicit, wow, I can't type, implicit deny and be dropped into the bit bucket. So if I say I want you to match the first 2 octets of that address with a wildcard mask, what would the wildcard mask be? Anybody? If I say match first 2 octets. Correct. Scotty said, in other words, the router doesn't care about the network, only the host portion. No, in this case, you're backwards on that. With this example right here, the router only cares about the first 3 octets. So it's only worrying, at this point, it only worries about the network portion, not the host portion. Okay? Now, if I was going to match these, it would be 0, 0, 255. So Scotty had this right, 255. So you're looking at the first 2 octets have to match. So that's what is meant by a wildcard mask. The great news is, typically to get a wildcard mask, all you have to do is subtract 255, 255, 255, 255 from the subnet mask, and you get your wildcard mask. Okay? So here's the IP address to be processed, the wildcard mask. It means it will match anything that is 192.168.0.0. So the zeros are significant. This is what we're looking for. And again, that's the opposite of a subnet mask. So subnet mask, the ones are significant. But again, the big thing here is a wildcard mask by itself is fairly useless because you have to be able to look at it and say, what is this wildcard mask compared to this IP address? You can do some generalizations. Like I said, if I just gave you this right here and said, this is a wildcard mask, what can you tell me about it? I can say, well, the first 2 octets have to match. And that's pretty much all I can tell you about it. So here's another example. This one's very interesting because this is 192.168.11 as my address, and my wildcard mask is 0, 0, 0, 0. That means all the bits must match. So that's looking for one host. If I did 192.168.11 and I did 255, 255, 255, 255, that means match nothing. Excuse me, anything. Second example, anything will match. Correct, anything will match. It doesn't matter. We're saying we're not comparing anything to it. So we're saying it does not matter what's in any of these octets. Because again, ones are not significant in a wildcard mask. So we're just saying we don't care. Anything can go through. And this final one here is if we're doing a /24 network, 0.0.0.255, you'll notice it has to be from any network 192.168.1.0. Does that make sense? By the way, we can replace this with any, and any will take the place of this. And we'll show you shortcuts here in a little bit. Now, look at this one. This one's interesting. What if we had a subnet and our range was 16 to 31, okay? And so we wanted to be able to do the wildcard range for that. You would have to look and convert the mask, whatever it happens to be. In this case, it was going to be 240, okay? And convert that into a wildcard mask by subtracting 255, 255, 255, 255 from it. So you'll see here with this example, this was the network, and I'm going to get rid of this, folks, so we have more room here so I can type. 192.168.16.0 / let's see, that would be 8, 16, 17, 18, 19, 20 / 20. Okay, so it's the SuperNet 172.16, and that is, since that would turn on this one, it's 1, 2, 4, 6, 8, 16. So it's actually 16 to 31, which is exactly what they're showing you here, 16 to 31. And our normal mask would be 255.255.240.0. So to get my wildcard mask, subtract that from this. And lo and behold, when I get in the right spot, my mask is 0, 0, 15, 255. And that's exactly the mask we have right here. Okay, that mask right there. Same thing here. If we had this particular network, now this is an interesting one, okay? Because they're asking you to find the odd or even networks. Last octet was a 0. Right. Sorry. Should have done 255. My bad. There. Fixed it. That's what I meant to type in. 255, 255, 255, 255. Subtract your correct mask from it, and you end up with 0, 0, 15, 255. Now look at this one. This one is interesting because what they want you to do is they want you to only pick the odd or even subnets or networks, okay, in this case. Now, this is a little wild because what you got to do is think about how IP addresses work. If the final bit is turned to a 0, you're going to have an even network. If it's a 1, you're going to get an odd network. So in this case, what they did was they said 192.168.1.0, and we know I'm just going to put 192.168.1.0, and we want only the evens. So what we do is, or only the odds. So what we do is we know that the third octet is 0, 0, 0, 0, 0, 0, 0, 1. Make sure that's 8 bits. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6, 7, 8. Correct. All right. Now we're going to take 254. 1, 2, 3, 4, 5, 6, 7, 8. And you'll notice it says we don't care about the bit positions in the first 7 bits. All we care about is that the bit position in the last bit is always set to a 1. So if I had this network, 192.168.2.0, and I look at the third octet, well, the third octet is 1, 2, 3, 4, 5, 6, 7, 8. Well, if I compare that to the wildcard mask, and I see that this is supposed to be a 1 in the last bit position of the octet, and it's not a 1. So this network will not match this statement. So if I did deny, or let's say permit, let's say I did permit 192.168.1.0 space 0, 0, 254.255, and a packet come in from 192.168.1.10, it's going to be permitted, okay, because the third octet has a 1 in the first bit position. If it come in from 2.10, it would be denied by the implicit. Just figured out that the implicit requires many characters from my right hand, and that's the hand that was more damaged during my wreck. Now check this out, 192.168.33.10. Would that one be allowed? Tell me if that one would be allowed with this statement that I have right here. 192.168.1.0, 0, 0.254.25. Patrick says yes. Scotty says no. All right, Scotty. Well, let's look at the third octet. 128, 64, 32, 16, 8, 4, 2, 1. That's 33, right? What is the value in the last bit position of the third octet? It's a 1. There you go. The only thing we care about, but with this mask, this wildcard mask, the only thing we care about is that the first 2 octets match and the last bit position in the third octet match. So this would be allowed. In fact, again, anything that was odd would be allowed. Anything even would be blocked. Why would you do that? Good question. Let's imagine you have a network where you have decided to give all your student subnets odd numbers and all your instructor subnets even numbers. Now, I don't think that's a great design, to be quite honest with you, but you could do it. I mean, you can do it. You can block it based on just subnet blocks too. But that is one way you could do it. You could end up with a network where even subnets went to one group and odd subnets went to another, and then you could use this to block or permit or deny, either one, based upon that. Plus, it's just a really good example to show you how wildcard masks work in conjunction with the IP address they're being compared to, instead of sitting there by themselves. And I think that's one of the hardest things to kind of get your head around, is that it is very important that you have the wildcard mask and the IP address that it's being matched to. So, any more questions on wildcard mask and how to calculate them? Again, you just subtract the subnet mask. Yep, good. I'm glad that helped, Scotty. You subtract the wildcard mask or subnet mask from 255, 255, 255, 255, and that will give you your wildcard mask. The only time that really doesn't work so much is when you're trying to match like a specific bit. Then you have to go back and start thinking about exactly what we did here and say, what makes that particular IP address unique or that range unique. 99% of the time it's going to be based upon the fact that you're using a subnet. So you'll just take the mask, take the subnet mask and subtract it from all 255s to get your wildcard mask. Now, there are some keywords. If we want to do like this one host, 192.168.10.10.0.0.0.0, you can, instead of typing out all those zeros, just put host in front of it. So you can say host 192.168.10.10, and this means the exact same thing as typing out this longer version of 192.168.10.10. You also could type out 0.0.0.0, 255, 255, 255, 255, which says ignore all bits, which basically says anything would match, okay? But you can use the keyword any to replace this. And then it would match any IP address. Because basically we're saying we don't care if anything matches, process it. You have to apply this to it. So there are two wildcard mask abbreviations that help a lot, host and any. So here's an example, access list 1 permit quad 0 quad 255s can be replaced with access list 1 permit any. And then this, we got quad zeros as your wildcard mask, can be replaced with access list 1 permit host. This is, to me, the host is easier to read too, because it allows you to see the logic behind it. I'm allowing this one host versus having to kind of think about, well, quad zeros. I mean, it's not that different, but it does help. A couple examples you can work on there. Now, what are some general ideas or guidelines? One is you can have one per protocol. So in other words, you can have one IPv4, one IPv6 ACL per interface per direction. So remember, each interface has an in and an out. So you can apply an IP access list or an access list on the inbound and outbound. But you can only do one IP4, one IPv6 in, and one IP4, one IPv6 out. And the big thing here is you really need to think about that person sitting in the middle as to what's in and out. So this would be outbound. This would be inbound. This would actually be inbound. So it has nothing to do with your network on either side, has everything to do with who that person sitting in the middle of the router. So some best practices. Number one, your ACLs need to be based upon the security policy of your company, of your organization. You need to really think about the logic of what you want your ACL to do. So you need to almost write pseudocode. I'm going to allow this host, I'm going to allow this subnet, I'm going to deny this, and then put it down so that you can figure out the correct logic. For most ACLs, you create them in a text editor and save them there, and then you can modify them as you need and put them back in. The other thing you got to be careful with is ACLs can be dangerous because if you do them wrong, they can cut you off from part of your network. Let's say you remote it into a router and you put an ACL in that blocks you from being able to get out. Suddenly, you're not able to get in your network. So be aware that you really need to test these in a test environment before you put them on your production network. So where do we place ACLs? Well, here's what I want you to think about. First off, let me give you a little example here. Standard ACLs filter based on source only, source IP only. Okay. You're going to learn later the extended, which are not part of the test for CSAN, ACLs filter based on source, IP, destination, IP, protocol, and even port. Okay, so I compare these two to standard ACLs are kind of like a shotgun. You just kind of get in the Patrick says you've done that. Yeah, I've done that too. That's where the reload command is your friend. You can say reload in 5 minutes, and the router will reload in 5 minutes. And you know, it's not great for users, but at least it will. If you don't save the config, it will drop that out. But standard ACLs are like a shotgun. You kind of get in the ballpark. Extended ACLs are like a rifle. You're dead on, getting exactly what you want to block, exactly what you want to allow. Now, when we look at these, one of the things I want you to think about a standard ACL. Let's imagine we wanted a standard ACL in this example that would only allow this source, 192.168.10.10, access to this network, 192.168.31.0. All right. Now, our access control list, since we are doing standard ACLs, okay, we'd have to use our source IP. So we would say access list, and right now I'll tell you it's a number between 1 and 99 or 1300 and 1999. Access list 1 permit host 192.168.10.10. So we're only wanting this host, one host, have access to this 31 network. Well, now let's think about this. What comes at the end of this? What if I don't put anything else? And in fact, some people actually do this. Some people actually go in just so they will remember, and they do access list 1 deny any, okay, so that they will see an explicit instead of an implicit deny. But by default, that's not there. We just have that implicit deny any. All right. So let's imagine that we put this as an inbound on gig 00. What would be the effect on any host other than 192.168.10.10 on this network right here? Okay, Scotty's saying nothing. Okay. All right, Scotty, I'm gonna get rid of this extended here. By the way, I'll tell you real quick. You place extended as close to the source as possible. Okay. You place standard ACLs as close to the destination as possible. That's going to have a very important item later. Patrick's saying it's blocked. Okay, let's look at this. So we do, a packet comes in from 192.168.10.15. So it's down here. It's just another host off of S1. It comes up. This is applied inbound on gig 00. So it comes in and it gets applied, and you look. So this is compared to this. Is this IP address the same as this one? The answer is no. So the next thing that happens is it will be denied. Yep. It doesn't match the ACL, and as a result, it has the implicit deny any applied to it. So what we've done is two mistakes. One is, the biggest mistake is, we actually created this ACL on the wrong router. To make it as close to the destination as possible, we should have created this ACL on R3. Then we should make an outbound ACL on gig 01 of R3. That way, if this host tries to go up to 30.0, it would come up. There's no ACL on this at all. It'll go across and have no problem. But if we've got it here as an outbound, it would only allow host 1010, which is what we wanted to do. We said we only wanted host 1010 to access the 31.0 network. So that is why standard ACLs must be as close to the destination as possible, because otherwise we will block unnecessary traffic, or excuse me, necessary traffic. The other network wouldn't be able to communicate. Okay? You're saying this 31 would not be able to communicate? Is that what you're saying? Correct. That is correct. Dot 11 would not. The only network that would be able to talk to the 31 network, the only host actually that would be able to talk to the 31 network, is the 192.168.10.10 host, the way we wrote this ACL. No one else in this entire network could talk onto the 31.0 network. Does that make sense, Scotty? Okay. Now, we could write this differently. Let's say we wanted to permit the whole network. We just do 192.168.10.0 and assuming the default mask. Now we allow everybody on the network on gig 00 on R1 to be able to go to this 31 network if we put it as an outbound on gig 00. So it all depends on how you write your list. Now, we still wouldn't allow 11, and we still couldn't allow 30 to get over here. But we are now allowing more than just the one host. We're allowing the entire network to be able to get access. So remember, standard ACLs, because they filter based on source only, need to be as close to the destination as possible. That will affect where you write the ACL, and it will affect where you place the ACL. So again, now they did it here. They actually put it as an inbound on the S01001. If you did that, though, it would actually block traffic to both networks. And then finally, they moved it down the correct place. They had theirs going to the 30 network instead of to the 31 like I did. So now, numbered ACLs are access list with a number between 1 and 99. That shows it's a standard ACL. 1300 to 1999 if you happen to need more than 100 or 99 ACLs. You basically have two items, deny and permit. Remark lets you add entries for comments, so you can actually put a comment in. And then you have your source IP and your source wildcard, and that is it. And then logging, log causes it to log messages about matching packets. So it's really a pretty simple command, access list 10 permit 192.168.10.0, and then you can do show access list to show it. You will notice that you get a sequence number. We'll talk more about that later, so that you can add items in to the access list without having to completely rewrite it or delete it. Many times, especially with numbered ACLs, it's better just to remove the ACL completely, rewrite it, and then add it back in. Okay. Now, one of the things about an ACL, it's a two-step process to create ACLs. You have to create the ACL, and then you have to apply the ACL. And that is extremely important because I see so many people make this mistake. It's not enough just to create the ACL. You can create the ACL all day long, but until you apply the ACL to an interface, it will not filter any traffic whatsoever. So this is true whether it's extended, MAC address, ACL, whatever, but you got to create it and then you've got to apply it. The command to apply it is the IP access group command. So you create your ACL, okay? You go to your interface and then you go IP access group 1 and then either in or out depending upon how you've decided it should be placed on your network, okay? In this case, they're doing outbound. They're only permitting a specific network and blocking everything else. So they have decided that only the 10 networks should be allowed to go across the serial link, and so they're putting it right here, okay, in order to go out. And it's not a great example, again, because you're not really knowing what the destination is. But it looks like the destination is the internet, and that's the only one they want to get out. So they're only allowing the 10 network to get out. And that's because of the implicit deny any at the end. So here are a couple examples. No access list 1 that removes the ACL. Then we've done an access list 1 deny the host 192.168.10.10. And by the way, deny statements typically always go first. Otherwise, if you wrote this the other way, if you put this statement first and a packet come in from 10.10, it would automatically be permitted. And remember, it's parental. Yeah, that's funny. That is a good one. Parental internet lockout. You just go in there and I don't know why it's not working, kids. But if you put this item first, then the logic of the ACL would permit anything that was 192.168.10, and so the deny would never work because it would be acted upon first. So if you reverse these two, your logic would be wrong, and you would not have the access control list you want. In this case, we're denying the 10.10 host, permitting everything else, and then making it an outbound. You'll notice, too, we're also denying everything on the 11 network because we have not specified that 11 is allowed out. And there's a typo. Oh, no, that's the second one. Here it is. This is a different one where they did the host and just put it in here. They're not wanting to deny the 11 network. They only want to deny this one host, and then they're permitting everyone else. So even though it is typically, the rule is as close to the destination as possible for standard ACL, sometimes logic dictates that it's better to do it a different way. So you really have to look at the logic on your network. Other than numbered ACLs, we also have a thing called named ACLs, where we can use the command IP access list standard and then give the access list a name. I hate when they use examples and make the name a number, which they do sometimes, which is crazy because it confuses you. But just be aware if you see IP access list, it's a named ACL. And then you have permit and deny and the exact same thing. So you'll notice here you go into a sub-configuration mode, config standard NACL, so configure standard named access list. And then it has the same commands we had before, permit, deny, source wildcard, log. And you still just apply it to an interface, IP access group name and out. Let's go back. I didn't show you the example. Here's the example. IP access list standard no access. By the way, if you put all caps here, when you apply it, it must be all caps. I see that all the time too. People will make all caps in one or just one. And yeah, it is easier to edit these because you do get the sequence numbers, so you can edit them. A lot of times, though, I just still like to do mine in a text editor and just remove it and then put it back in because I just make too many mistakes when I try to edit it and make mistakes. But so a couple packet tracers and a couple. Here's ways we can edit it. If we are creating ACLs using text editor, we can put them all in and then paste them in. If we see we've got a mistake, you can remove the access list completely, change it in your text editor, and paste it back in the global config. That's one way to do it. The other way is using sequence numbers. You'll notice even with non-named ACLs, you do have sequence numbers now in the iOS. So you get access list 1 deny host blah, access list 1 permit. You'll notice by default the sequence numbers are 10, 20, 30, so on and so forth. You could then go in and access list, IP access list standard 1. Actually, that's a mistake. That should be IP access list. They're right. It should be a named access list. Okay, not a standard. So that's wrong. That should be IP access list 1 deny. But then you can do no 10, which removes the 10 statement. Okay, because I messed up. I put 99 instead of 10. And then you can literally go in and say 10 deny host, and it will put it back in the place of that 10 statement. What's even cooler is you can add an 11, 12, 13 through 19 if you need to add something in between these. So imagine we needed to deny 10, 12, and 14. You could actually do those 10, 11, 12 statements and deny those. So it is important that you know that. It's also the easiest way to do your access list. So, and again, that should have been extended ACL. Excuse me, named ACL, not extended. Named. Here you see your show access list, and you notice here you've got 10 and 20. You can go in here and say IP access list standard no access, and you can stick a host in the middle. So again, you can do 15 and stick in a new host to deny, since you want your deny statements before your permit statements in almost nearly every case. Show access list will show you your access list. Show IP interface, and then the interface number will show you what lists are set in and out. Remember, you can never have more than one list in per protocol, per port, per direction, or out. And somebody's dropped. Okay. Show access list will show you all your access lists. And if you've got the log statement, it will show you what has matched that access list. And that's where you can get it with this using the log statement. Matches. Actually, it does it by itself without logging. It will do it based on the matches. If you want to clear it, you can do clear access list counters to get that. So that's where we've cleared the counters. It's important with, it's a good troubleshooting step, especially with students, because you can go show access list. If they're not being matched, then you know probably they haven't applied it to the correct interface, or they don't have it applied in the correct direction. It's also really good when you're doing crypto ACLs down the line, which helps you see whether or not traffic's being defined as interesting or not, which is a different beast from what we're doing here. But the last thing in this chapter that we really need to talk about is using access lists to control access to the VTY line. So what we do is we go in, we do login local. Let's just put our local username. Transport input SSH. All right, that only allows SSH. By the way, in iOS 15 or higher, the default is transport input none. And so I see so many people configure SSH completely or correctly and forget to put this in, and it will not work, and we can't get in. So make sure they set the transport input. You got access class 21 in, and that's an ACL that says access list 21 permit, and it's this one network. And then deny any, they put that in here instead of using the implicit deny any. And once you do this, and by the way, access classes will always be in. There's no other way to put them onto a VTY line. This will only allow hosts from this network to access the VTY lines via SSH on R1. So this is something that should be set up on every single router that you control, that you're doing an access class command, an ACL, to control VTY line access. Does this make sense? This, by the way, has no effect whatsoever on any traffic flowing through the router. It only has to do with traffic going to the VTY lines on that router. And so you can do it here, you can log in or not. So 11.1 is getting connection refused, whereas 10.1 is giving the login prompt. Again, the implicit deny any at the end, it's always there. You don't have to put it in. You can if you want to, though. The order of the ACLs, you'll notice this will even the ACLs have an internal logic, the iOS does, and so it will tell you what will and won't work. So in other words, if I try to do this, access list 3, deny, 10-0, and then permit, it will say, whoa, this won't work because the rule above it is overriding this. And so it tries to keep you from making mistakes. You could then put a sequence number of 9 or 8, and you could put this actual statement in front of the other, or just remove it and rewrite it. Okay, which most time you always put the host statements before the range. And you can do it though if there's no conflict. So here you've got denying the 10 network and permitting that one host. So, but honestly, if I was going to do this ACL, you're denying this network and you're permitting this one and denying everything else. Why not just make the entire ACL access list 5 permit host 192.168.11.10? The only reason you wouldn't do that is because maybe you've got a majority of traffic from the 10 network and you want to drop it before it has to all be processed by this one entry. And Patrick asked, what in practice, what filter is usually used on the B2I ACL? The filter is usually set to the management IP address subnet. Now, in super secure networks, it may actually be a specific management host. The only problem you have to be careful with there is if you set it to one single host, if that host for some reason goes online or there's an offline or there's a denial of service attack against that host, you will not be able to access your router. So typically, it's set to the subnet range of your management network on your network. Does that make sense? Whatever that happens to be. Yep, you can have a DDoS on a host. It happens. Especially if I was doing something to your routers and I wanted to be able to take them down and I wanted to make sure your management couldn't get to it too. I would do both. So here's an example of range network statements and host statements. What happens though is if you put this in, the iOS will actually go in and rearrange it. It will actually figure out what's the best order, what should be allowed. So these are the hosts that should be permitted, and these, and it will actually go through and say, from our internal logic, this makes more sense than what you did. And so it will actually try to go in and make it make sense versus when you do a copy run start, you'll see it rearranged it, and then when you save it, it actually rearranges it in the actual sequence numbers too. So the iOS is intelligent enough to try to make things right. You just have to keep an eye on it, make sure it's actually doing what you want. This is a very interesting flowchart because it shows you what happens when a frame comes in on a router interface. Is the layer 2 address matched? If no, well, obviously it's dumped into the bit bucket. If it does match the layer 2 address or the MAC address of the router, it goes to the ACL. Is there an inbound interface, or excuse me, an inbound ACL on the interface? If no, it goes to the routing process. So Seth will do a quick lookup and send it where it needs to go, and then it will look for an outgoing ACL. If there is an inbound ACL, it will look and say, is the first statement in the list, the first access control entry, is it a match? All right. If yes, then obviously it would forward it and do whatever it says, permit or deny. If the first statement didn't match, it would look for the second statement, then the third, then the fourth. Then it will go all the way down, and if nothing matched, you go into the default deny, which throws you in the bit bucket. Let's imagine it is matched, however. Okay. So now it's being matched, and it comes into this permit, and it's allowed. So we say yes. If it was a deny statement, it'd be thrown in the bit bucket. So it's allowed. So yes, it goes into the route lookup process. Then you go out here, and is there an outgoing interface? If outgoing ACL on the interface, the answer is no, it just goes out. Okay. If yes, then it looks for the same process, it looks for a matching state. Why this is important is because when you look at this, if you can filter the traffic before this forwarding decision is made, it requires less work from your router. So in other words, if you put an outbound ACL, which sometimes you will have to, but if you put an outbound ACL, the packet will be completely routed before it's dropped. So if the outbound ACL is dropping the traffic, you really want that to happen beforehand so your router doesn't have to go through the route lookup process and then just to drop traffic on the way out. So that's really what this is most important, is to kind of think about how do we most efficiently make use of the resources on our router. Now, they go through a bunch of examples here, and I'll let you look at these and read through them, but basically it shows you how to set up just basic, allowing single host, allowing subnet, allowing particular access control, particular host in on V2Y line. Notice this is a named V2Y line, which is fine. The single host is allowed. No big difference there. And that is pretty much, folks, Chapter 7, Access Control List. Are there any questions? All right, let me see here what my question is in chat. How long one here? Yeah, it tries to put the most likely matches first. That's what it does. It tries to look at the most likely matches based upon the logic of the ACL. So, all right, couple things. Since this is going out to the whole class, make sure everyone knows that class does end next week. But one of the things I want you to be aware of is it only ends on Moodle. So I need you to go in. No, it uses internal logic. It doesn't use traffic stats to do that. It uses internal logic based upon longest bits, number of bits have to match, and those items. But remember, the only thing you're losing access to next week is the Moodle class. So I do need you to log into Moodle and just log in and show that you've logged in. I need you to then continue to work in NetLabs and NetAcad, which you will continue to have access to. And you have access to that up till September 12th. And then you will need to be completed so that you can go into your next class, which for you will be scaling, which I'm also teaching. If you have questions about our schedule and need to sign up for class, you need to go to our Stanley web page, go to the ASC ITC page, instructor training, class schedule, and right here's our schedule for the fall. And you can contact Rita Likey and get in touch with her so that you can get signed up for the scaling class in the fall. Okay, I'm going to stop the recording, folks.